Alabama STEM Explorers is made possible by the generous support of Hudson Alpha Institute for Biotechnology, Southern Research, solving the world's hardest problems, the Holly Family Foundation, Alabama Works, Alabama STEM Council, Alabama Mathematics, Science, Technology, and Engineering Coalition for Education, Alabama Math, Science, and Technology Initiative.
I can't wait to go to the Gulf of Mexico. We're gonna go swimming and see some sea life, maybe even a shark. I don't know too much about the sea life though, so I think I know someone who can tell me a little bit more. Hi, and thanks for joining us today on Alabama STEM Explorers. I'm Anderson, and this is our friend Nicole from the McWane Science Center.
All right, so today we're here at the touch tank in the world of water. We have two types of stingrays in here. We have southern stingrays and cow-nose rays. And both of these stingrays can be seen near our beaches in Alabama. We also have two types of sharks. We have white-spotted bamboo sharks and an epaulet shark. White-spotted bamboo sharks are found near Asia. And so, Anderson, do you want to try to pet some sharks and stingrays today?
Sure.
All right. So we're going to use 2 fingers, and we're going to wait for them to swim by and then just pet them gently on their backs.
Okay.
It is a little bit of, you need some patience for this. So we're just going to see if they swim by, and then we'll try to pet them. We feed them different types of seafood throughout the week. We do have a public feeding on Wednesday afternoons. If you're ever in the area, stop by and check that out.
Do you know what their favorite food is?
Oh, they really like to eat shrimp. So they love shrimp. We also feed them clam and squid and salmon. So our sharks in here lay eggs around this size, so maybe palm size. And we do have male and female sharks, so we get baby sharks sometimes. Here's a cow nose. Oh, so close. So we collect the eggs and wait for them to develop, and once they reach adulthood, they'll join their parents back in the touch tank. Now, if we do get to touch a shark or stingray today, our sharks feel a little like sandpaper, and our stingrays are a little bit more slimy. So we'll watch for that. They're not being very cooperative.
Do their tails help them swim at all?
So they do help them rotate in the water, so kind of like a boat rudder.
Yeah.
If you move it to change directions. A lot of their barbs lay on top of the tail, so that's the part that would sting you. So some people think that their whole tail is the stinging part, but it's just on top of the tail, and it kind of grows like a fingernail. So here we're able to clip them off, and it's safe for us to touch them.
I also noticed that they have like they use their body as wings kind of.
Yes, so the southern stingrays have that undulating motion, and that is exactly like a wing. Helps them underwater move. The cow-nose do more of a flapping, like a bird. All of those propel them forward in the water.
Do you know if they can swim backwards or not?
Ooh, that's a good question. I think that they do sometimes.
Do they have to come up for air at all? Because I see them coming out of the water a lot.
That's a good question. They do not have to come up for air. So these guys have gills, so they breathe underwater. They do come up to splash, to kind of feel around their habitat, so they explore. But they are able to sit on the bottom. All of these animals could be found on the bottom of the ocean. So sometimes the stingrays will bury themselves. The sharks also sit on the bottom. All right, so I have a few pieces of food here to see if they'll come up to us. If you are comfortable just holding on to one.
Is this water drinkable?
No, it is not. So we make a lot of salt water here since we don't live near the ocean. We can't just take the salt water from there. So we make all of our salt water, and this is about 7,000 gallons of salt water. So you would not want to drink that.
What's the weirdest thing you've ever seen happen to a stingray?
That's a good question.
Or happen in this touch tank?
Okay, so sometimes people are reaching really far to pet one and they fall in. Yeah, but that's okay. I go swimming in here sometimes on purpose. So we'll just grab them a towel and we have some extra shirts and it's a cool story.
Yeah.
So as we can see, our stingrays are not trained to come to people. They live in here all the time, so we respect their space and allow them to do what they want in here. So here's one of our southern stingrays.
Are those ears, like the holes behind its eyes?
That's a good question. The holes behind their eyes are called spiracles. Their gill slits are on the bottom along with their mouth. So this lets them sit flat on the ocean floor and still be able to breathe. So they can pump the water through there. So our sharks and stingrays have spiracles. Not all sharks have them or are able to stay still. Some of them have to keep swimming all of the time. So that is what most people think of when they think shark are the big great whites or hammerheads. And those guys have to keep swimming all the time. This is our touch tank, but let's go check out our Gulf of Mexico exhibit.
Okay.
You want to get in and swim today?
Yeah.
It'll be fun.
Okay.
Welcome back, and we're at the Gulf of Mexico in McWane's World of Water exhibit. We are so excited. Anderson and I have our cool wetsuits on, and we are about to go for a swim. Nicole, tell us a little bit about what we're getting into.
All right, our Gulf of Mexico exhibit is our largest exhibit. It has 10,000 gallons. Now, you'll probably be able to stand up in there just fine, but you're gonna go swimming, and this is just how we clean this exhibit. So we get in there and we scrub the rocks and vacuum the sand to keep the water healthy for our animals. In there, you're gonna see animals that you would see in the Gulf of Mexico. So our most popular animal in this exhibit is our green moray eel, Mo. And he's out in this cave. He's taking a little nap right now. You'll also see spadefish and pompano and look down and several other fish that you would see if you went to the ocean in Alabama. So you all ready to go?
Let's go!
Ready? 1, 2, 3. All right, here are Anderson and Kathryn in our Gulf of Mexico exhibit. So this exhibit highlights the water we would find in our area, the coast of Alabama. So we have spadefish, which are these black and silver striped fish. Pompano, which are popular for fishing. Mo, our moray eel, is about 5 feet long, so he's a little shorter than I am. So he's kind of wrapped up in there in his cave. Moray eels typically hang out in cracks or crevices in rock or coral, and so they're just there. So we use a similar method to clean this exhibit. We scuba dive in there, and they are snorkeling today. So we'll go in there about once a month and scrub off the rocks, do a water change, make the habitat healthy for our animals. Visitors can sometimes see us in there cleaning. We also do a public feeding for this aquarium on Wednesdays and Fridays at 1:30, so visitors can come and see what we're feeding the animals that day, hopefully get to see Mo eat. Mo eats for us about once or twice a week, and he is station trained, so he comes up to the top, that's his station, and we'll hand him his food. He doesn't have to eat that often because he's not overly active. He normally is in his cave like eels would do. They are nocturnal, so he might come out at night. We're not usually here, but he might come around and swim. Moray eels, so he's green, but their actual skin color is brown, and they have a yellow mucus on them, which makes them green. So he's very slimy. He also has pretty sharp teeth. So that's how he would catch his prey. They also have a second set of jaws kind of in their throat. So when they eat, they'll use the jaws to grab their food and bring it down to their stomach. So we feed him mackerel here at McWane. They eat fish similar in size, so a foot or so or less, and then pretty skinny. They have been known to eat octopus. If they eat something that's bigger than maybe their mouth, they can wrap up, kind of like a snake, and rip it apart. The fish in here, we feed chopped up pieces of seafood. So we feed them squid and clam and shrimp and krill, different throughout the week. So they're getting their full range of diet.
I had so much fun swimming with the eel and fish here at McWane Science Center. I can't wait to go swim in the Gulf of Mexico with all kinds of fish.
I'm the senior aquarist here at McWane. As an aquarist, I feed the animals and care for them, so cleaning their habitats, making sure their water chemistry is correct for them. We change filters, anything that's related to these animals' lives, we take care of that. So I've always been interested in animals and the ocean, and as a kid, I read lots of books about people who were marine scientists and the animals, so it just kind of interested me more, and I just kept learning about that. And as I went to college, and then I started volunteering here. I was good at math, but I think my favorite subject was biology. Biology applies a lot for our animals, so we need to know how they work, what they eat, where they would live. So we take that all into account when we are acquiring fish so that we know we can care for them properly. And then while they're here, we need to monitor them and make sure they're living their best life. So biology of the animals is important. Math comes into play and physics, mostly with the water. So these are all closed systems, so their water moves through a filter and back to the aquarium. So we need to know how the water is working so that we can keep it safe for the fish. Part of our job is the water chemistry, since these animals live in the water full time. So we need to make sure that their water chemistry is correct to where they would be living in the ocean. So we do weekly water tests on all of the water to make sure that it is safe for the animals. So we test for ammonia and nitrate and nitrite, so all the parts of the nitrogen cycle. And then we test the salinity and the pH and dissolved oxygen, everything to make sure that their ecosystem is correct. I enjoy learning about the animals' personalities. So each fish kind of has its own favorite spot in its habitat, or they come up to you for feeding. So just learning those and kind of their habits and how we can make their lives better. To a middle school student interested in working with marine animals, I would recommend reading about the animals, just figuring out what you're interested in and learning as much as you can. You can come visit aquariums or science centers such as us. You can talk to our educators and aquarists. Just figure out what we do. We have a program called Aquarists for the Day. We also offer camps that are related to aquariums. So you could get involved in those, volunteer if you're able to, and just try to get involved however you can.
Hey, we're at Alabama Aquarium at Dauphin Island Sea Lab, and we're here to look at all sorts of sea life. So, Carissa, tell me what's in front of us right now.
This is our Shark and Ray touch tank. It is a hands-on experience for people. It has 3 different species of stingray in here, our Atlantic, our cownose, and our blunt nose, and 1 juvenile bonnethead shark, as well as some of our mullet fish in here. And people are always welcome to come up here and touch these guys.
So, we're going to talk about the stingrays.
Yep.
What is their defense mechanism?
The defense mechanism on the stinger is going to be the barb. A lot of people mistake it and call it a stinger. The barb is a piece of cartilage that grows on them. People often think it grows at the end of their tail, and that's actually not where it's found. It's found either at the base of the tail, like it is for our cownose rays, are about halfway down the tail like it is for our blunt-nosed stingrays in our Atlantics.
So their eyes are on the top, and what's the thing next to the eyes? What are those?
Those are called the spiracles. Spiracles can be found in rays and sharks that are often bottom dwellers and that don't have to swim to keep breathing. So like our blunt nose is demonstrating right here, she'll pull that water over in through there and push it over her gills, which are found on the bottom. So it allows her to sit still on the bottom and not have to keep swimming to breathe like fish have to.
So they're like extra gills?
Not quite extra gills, but it's kind of like how we can breathe out of our mouth and our nose. It's kind of like that, how you can still have your mouth closed but still be able to breathe.
And their gills are on the bottom.
Yep, they're going to be found on the bottom.
So we're going to feed them, right?
Yes, we are. So we have today to feed them this vitamin gel that we make in-house. It is a shrimp flavored gel that we make using shrimp, gelatin, and a special shark ray vitamin. It's to make sure they get all their vitamins that they need. It kind of reminds me of a Flintstone gummy. So we feed this to them first thing in the morning to make sure that they eat all their gel, and we just kind of scatter it throughout the tank to make sure everyone gets at least one piece of gel. So we can just kind of throw it somewhere in the tank, and they can fish it off the bottom.
Yep. Can't throw it far.
Yep. Gotta make sure we scatter it for some of the ones that don't want to come all the way over here. And then we just make sure that everyone we see is eating, make sure that they're staying nice and healthy. Easiest way to know an animal is sick is that they will stop eating. Kind of like we do when we're not feeling well, we don't want to eat some food.
So I see some rays just buried in the sand.
They will do that as a defense mechanism and also as part of hunting. So they'll bury sometimes to hide from a predator, but also to help them find food. Some of them are ambush hunters. So what they'll do is they'll bury in the sand, blend in, wait for food to swim by them, and then pop out and grab it.
So would you just find these randomly in the ocean?
These guys are found in the Gulf of Mexico in particular. And for most of them, they can be found close to shore to a couple hundred feet off the shore.
Carissa, tell me what's in this tank.
Well, in this tank we have 2 Atlantic horseshoe crabs. The Atlantic horseshoe crab is the only species of horseshoe crab found here in North America. There are actually 3 other species of horseshoe crabs that can be found over in Asia.
Explain to me what these basically are.
Horseshoe crabs are weird. Despite the name, they're not actually related to crabs. They're actually more related to spiders and scorpions. We can tell that based on the fact that they have far more unique shape, but things like 10 different eyes. So these 2 that people can see very well, it's your compound eyes, as well as the 8 different photoreceptors they have. So 3 are located right there on the nose, 1 on top of each of the compound eyes, 1 at the base of the tail, and then 2 are found underneath. The other thing that makes them more related to spiders and scorpions are these book gills they have on the back. So instead of having normal gills, they have these book gills that can be lifted up.
So yeah, it does look like a spider. And then what is this tail right here?
The tail is known as the telson, and it is used not for defense like a lot of people see. They think it's like a stingray tail.
Yeah.
But they use it more like a rudder and to help flip themselves over when they end up on their backs.
So what are all these right here? Explain to me what all this is right here.
These are their legs. You can tell based on these front claws. Only males will have these claws right here. We call them boxing glove claws. Females will just have another set of these legs. And the way to also tell this is a male is because males won't get much bigger than this, but females will get about 3 times this size. And in the very middle is going to be their mouth.
Their mouth. So can you feed?
Yes. Would you like to try?
Horseshoe crab.
Yeah. Would you like to feed him?
Sure.
All right.
So what is this stuff right here? What are you feeding him?
These are shrimp pellets. They're like vitamins for them. So they have all the nutrients they need to make sure they can grow healthy and molt properly.
So do I just get a couple out?
Yeah, you can just take a couple out and just drop them right directly into his mouth.
Okay. Ooh.
So when they eat, they don't really chew their food, they just kind of shove it directly into his stomach.
Yeah, that's really cool. I'll just feed them a couple more.
Yeah. They get fed vitamins once a week just to make sure they are staying nice and healthy.
Yeah.
Like we take vitamins.
Okay, so what is this shell right here? What does this shell do?
The shell is protection. That is their only defense. Most crabs use claws for defense, but these guys' claws don't hurt at all when they pinch you. They're just used to pick up dead things and worms, stuff out of the sand. So this hard shell is their only protection. And these spines are just to keep things from going underneath. They're not sharp at all.
So what if they didn't have the shell?
If they didn't have the shell, they'd be pretty defenseless. Things would be able to eat them really easily.
Yeah, well, can I hold one?
Yeah, sure, welcome to hold him.
Wow. This is really cool.
Yeah. They're a unique animal. They have been around since before the time of the dinosaurs, since the Carboniferous time period. So they have been around since most modern life today, and really haven't changed their body structure at all, so.
Well, yeah. Thank you for showing me all this.
Yeah, thank you for coming to learn about them.
I study animals that live in sediments and sort of the ecological role that they play in their environment. So probably the most commonly known thing is that they're fish food, and so a lot of people care about them because they feed on the organic matter in sediments and then wrap it into a nice tasty worm, and then the fish eat them. But they also do what worms in your garden do. So they mix the sediments around and bring oxygen down, and they regenerate nutrients, and that can be really important in terms of what they pee and poop out. Regenerates nutrients that then fuel phytoplankton growth, and that's really important in shallow areas like Mobile Bay and the coastal environment here. I got really interested in worms because they're very ecologically important, but it's very hard to study them because they live in mud and you can't see them. And so in order to be able to study them and understand what they're doing, I had to come up with a lot of kind of new techniques and figure out how to study something that you literally can't see. So in order to do that, I've had to learn a lot of engineering techniques and apply those both in developing new methods to observe them and also kind of understanding some of the engineering theory that I then apply in my work. So I collaborate with engineers, and I took a lot of engineering coursework, so I have a strong engineering background, but I'm really a biologist who kind of dabbles in engineering. I'm not a legitimate engineer. When I was in graduate school, I found that worms actually burrow through muds by cracking their way through. So people had thought about worms sort of eating their way through mud, but in fact, the mud is very cohesive, so it's kind of like Jell-O. And so I actually used Jell-O as a transparent analog for mud. So I spent several years making giant vats of Jell-O and then sticking worms in it and watching them move and thinking about how that related to what they do in mud. And so what they do is they actually push against the walls of this crack-shaped burrow, and knowing a little bit about fracture mechanics helped me understand that they do that, and the forces that they apply are actually amplified at the tip of the burrow, and it causes the burrow to open up, and so they can move forward into that space. And that was really important because people had thought about burrowing as being really energetically expensive. Like moving through dirt does not seem like a good way to move. Like we run and we swim and we do all these things that are much easier than that. And so there was this sort of big question of why would they bother to burrow if it's that hard? And so my research has showed that it's not actually as hard as people had thought, which kind of helps us understand why there are so many different organisms that burrow in sediments and that live in this habitat. So I think one of the coolest things about what I do is that it's very interdisciplinary. So, I got interested in it because of biology, but as a kid was always very good at math. But I didn't really realize that my math skills were important in the biology that I was interested in. And so once I kind of realized that, like around high school, as I was learning more about marine science, I was like, oh, I really need to pay attention in math. I can't just coast through because it's not that hard for me. And so I didn't have a good understanding at that age of how much of all of the different things I was learning would tie together in what I do now.
Thanks for watching Alabama STEM Explorers. If you missed anything or you want to watch something again, you can check out our website at alabamastemexplorers.org. Maybe you have a question we could answer here on the show, and you might grab a cool t-shirt. Feel free to send us a video question or an email on our website, alabamastemexplorers.org. Thanks again for watching. We'll be back next week.
Alabama STEM Explorers is made possible by the generous support of Hudson Alpha Institute for Biotechnology, translating the power of genomics into real-world results. Southern Research, solving the world's hardest problems. The Hawley Family Foundation, established to honor the legacy of Brigadier General Everett Hawley and his parents, Evelyn and Fred Hawley, champions of servant leadership. Alabama Works, a network of interconnected providers connecting business and industry needs to a highly skilled and trained workforce. Alabama STEM Council, dedicated to improving STEM education, career awareness, and workforce development across Alabama. Alabama Mathematics, Science, Technology, and Engineering Coalition for Education, advocating for exceptional STEM education in Alabama. Alabama Math, Science, and Technology Initiative, the Alabama Department of Education's initiative to improve math and science teaching statewide.